Welcome back. The last step in the machine learning workflow, once you have trained, evaluated, and finally chosen a model after multiple iterations, is model persistence, deployment, and monitoring. In this video, we will look at what these terms mean in detail. So let's get started. Let's begin with model persistence. Model persistence refers to the process of saving a developed model so that it can be used later. Building a model requires time and money, and so saving it so that you can use it later when needed without having to recreate it from scratch. Makes sense, right? Just like what you do with any other file, whether a Word, Excel spreadsheet, a PDF, etc. Also note that model sizes vary. A simpler model could be a few megabytes, while larger, more complex models can go up to a few gigabytes. Next, we have model deployment. This is the stage where the saved model is finally put to use, enabling our devices to make smart decisions based on data they receive in real time. When deploying models, several factors need to be considered. This includes the computational power of the device, the size of the model, and ensuring that the model input during deployment matches the data types and structures used during training. For example, if you built a model with tabular data containing 5 features or columns, then those same 5 features, in the same order and same processed state, need to be used when you are using the model to make a prediction. Or if you built a computer vision model with images of size 96 by 96 pixels, the new unseen image that you send to the model should also be of the size 96 by 96. Going deeper into deployment can take different forms, from simple APIs for mobile and web apps to more complex deployments for edge devices. For instance, a news app that recommends new articles based on what you read, or a banking app that takes your image and documents and performs KYC online are both examples of API deployments. An example of an edge deployment could be a traffic monitoring model deployed on city cameras to adjust traffic lights based on real-time traffic conditions. Finally, let's talk about model monitoring. Once a model is deployed, it's crucial to keep an eye on its performance. Model monitoring involves continuously checking to see if the model's predictions are still accurate over time. This is necessary because over time, data can change, a phenomenon known as data drift, or the relationship between the input data and the output may change, which is a concept popularly referred to as model drift or decay. In these cases, ensuring consistent performance can involve periodic updates or retraining of the model with the latest data. For example, a model used for predicting customer preferences in an online store might start performing poorly if new trends emerge and the model fails to recognize them. Thus, monitoring and updating the model is key to keeping it relevant. And that is all for this video and this mini section on machine learning workflow. In the next video, we will look at the different machine learning techniques, namely regression, classification, and clustering. So, see you there.